Okay, this is Michael, and he's from Knoxville, Tennessee. And Michael came in and kind of took over where Skip left off from the DC and the 24. I'm sorry, the DC and the 12-volt system that is part of GeniGreenelectric. We've decided to call him TieDye Michael, basically because he likes tie-dye shirts. And there were like 5 or 6 Michaels around here, so he became TieDye Michael. So what do you think of the GeniGreenelectric?
Well, I love it. It's an amazing boat, an amazing technology, I think. Glad to be part of it.
So what did you actually start in and do and well, were able to that you finished?
I started right here with 2 bilge pump circuits that we ran to the port side, and from there we started running wires here to go to the new DC panel. We put in a completely new DC panel and all the new DC wiring for the system.
We're almost finished. Not quite finished, but we're getting there.
This is one of our last.
And what's that? What's that wire going to be used for? It looks like it's like a 3-wire or something.
This is a 6-conductor cable, and it'll be used for the lights on the mast, and also for the radar power.
Okay. Well, you know what? I don't have to use the radar. Wait a minute. We don't. Basically, this will be the panel for the 6-wire for the mast lights and everything, and those will go to the helm, which we'll show you in just a second. And then he also worked at the inverter charger. It's actually a DC to DC converter. It's made by Victron Energy, and it's an 80-amp charger, but it is designed to charge from 144-volt DC to 12-volt DC. So it handles any of the charge loads that our DC may need. Didn't show much on before, but I will show as part of this video. We'll go back and forth, but part of this is we made a decision from the old 12-volt system that was installed in 1992 to put in a new Paneltronics. This is a 24 breaker panel that has a 100-amp main that has manual meters on it, but it gives us everything we need and the information we need on the loads, on how much voltage we have and what we need and what we actually need. There's the breaker panel will be described on our website, and what breakers were involved and things like that. Maybe put it up through on this video too. But Michael, why don't you show us what you did and how that worked out? We have this wire that we brought up from the battery up here. We brought that wire up and put it into the 2 blocks, so that and then we took. Go ahead and tell us what you did. Okay, from this main bus, the power goes down to the panel through these 2, the red and black cable. Okay. We basically wired the panel with new circuits that we've run to various parts of the boat. Everything is marked and labeled, of course, by number and by the function that it's doing, so we can trace it easily to the other end. And we also have a legend of the breakers, the breaker numbers that do various functions, so we can have labels made for the front. And here's our DC panel. So you can see that the DC's coming up. It's coming up to 13.2 or 8. 13.2 it looks like. Yeah. And that's coming, and that's not only the 12-volt system doing that, but it's also the DC to DC inverter that will constantly keep that 12-volt charge. There'll be very little usage of the 12-volt because of the DC to DC converter. But this is the panel. It's got all sorts of breakers. We've got 5-amp breakers on here. We've got 10-amp, 15-amp, 20, and 30s. We had 130, which is the air conditioning system.
And 140 for the helm.
Okay. Yeah. Oh, yeah. We have a helm, so that goes all the way to the helm. Okay. So you put that panel in. So that's a lot of work.
Took a few days.
Yeah.
Took a few days.
You've been here for about a week, haven't you?
I have. This has been a very good vacation.
Yeah. And now he's going to go home and rest. But we've got a long way to go if you think about it, and we'll show you the pictures in here. If you'll notice that the old panel system was nothing but a bunch of buttons. You never could trace it. And one of the last things we got to trace out this morning was the windlass. Go windlass.
Yeah,
so now we have an active windlass on the boat.
It's right here.
Yeah, so I can turn on and everything. Okay, well, thank you. You know, TieDye, I got to tell you, I appreciate you coming down and doing everything you did and making the boat ready for the boat show. I wish you could stay a little longer, but you know, we get to see you back if we let you go.
Well, thanks for having me. It's been a really good experience.
Yeah, thank you.
Well, when I came down here, I've been developing, along with some other people, a 48-volt pontoon boat back in Knoxville, where I'm from. And I wanted to see the 144-volt system that they're using down here and see what the differences are. I couldn't quite imagine, just hearing the difference in voltage, what the difference in the system could really be. It's quite amazing what the difference is. This one using a DC servo motor essentially is a drive motor controlled by an electronic controller. Very different technology from what we're using back home.
So what you saw it in the water today, and you saw it tested in the torque involved. You're already used to electric motor torque,
right? And
the name of your boat is
the GreenTech 1 and the GreenTech 2. The GreenTech 1 is a small fishing boat with a solar canopy. We recycled an outboard motor, taking off the gasoline components and installing a high-efficiency electric motor where the gasoline components had been on that. We used the original part of the outboard motor and put that on the back of the boat. It's a souped-up trolling motor. It does about 6 knots on the lake, and with the solar power, the solar panels on the canopy putting power back to it all the time, you can just run around the lake with it all day.
And how many volts was it? How many volts did you set up?
It is a 36/48. It can work either way.
Okay, so 48 volts maybe make it.
We've actually found that one works better at 36 because when we add another battery, it adds quite a lot of weight to a 10-foot boat. So we found it really, the fourth battery to achieve 48 volts is not worth the weight that it takes for it. So we operate that one on 36 volts.
Cool. All right.